Okay, before we start plotting points here in this example, polar coordinates work different than Cartesian coordinates. You know, Cartesian has an x and a y coordinate like 1, 2. We call them rectangular coordinates because 1, 2 means you go 1 to the right and 2 up. It's like you're moving in a rectangular fashion, right? So with polar coordinates, it's just a different way of graphing those points. With polar coordinates, we have an r and a theta, where r would be like kind of like the radius. It's like the distance from the center of the circle. Okay, that's r. And theta is the angle. So if you remember that pi over 2 is equal to 90 degrees. Here, let me just put an example here. 1 comma pi over 2. This means you need to be 1 away from the origin, 1 unit away from the origin, okay? And you need to be 90 degrees from your initial side. So here's my initial side, rotating 90 degrees gets me here. There's my dot, and that should be 1 on the x-axis. Okay, that's that point 1 comma pi over 2. Sorry, I'll try to clean up my handwriting as we go along here. But let's do what we've got in Alex here. We got to plot the point 4 comma negative 4 pi over 3. Okay, so in order to make that happen, we can note that the angle is negative 4 pi over 3, so when we graph that in the Cartesian coordinate grid, yeah, so negative 4 pi over 3, maybe it's easier to look at that in terms of degrees. The quick trick for converting from radians, which is what we have now, to degrees is you multiply by 180 over pi, and then you've got your degrees. Okay. In other words, it cross cancels your pi, and then you've just got to multiply your fraction times 180. So 4 times 180 divided by 3, that gives us negative 240 degrees. And from previous practice, we know negative 240 degrees. Negative means we rotate the opposite direction. We're going clockwise. And there's negative 180. So we don't want to go negative 270. We're somewhere around here, right? Because this is negative 270 degrees. This is negative 180 degrees, so we're close to 270. That's the angle that we need to draw. And then we also need to put a dot somewhere. Maybe the dot should be here on the angle, on the terminal side of the angle. Maybe the dot should be up here. Maybe the dot should be up here. The way we know where the dot goes is that the dot needs to be a distance of 4 away from the center. So that's why in Alex they've got these hash marks for you to help out. Okay, oops, and I think we'll need to convert back. Right, so this is where negative 4 pi over 3 gets us. See how everything is in terms of like 0, pi over 6, pi over 4. They're in terms of positive radian measurements. So we've got to put our answer back in terms of positive radian measurements. I think the quickest way of doing that would be, 2 pi is the full circle. And if we, 2 pi is 6 pi over 3. And so we went 4 pi over 3 in the backwards, sorry, yeah, that's right, 6 pi over 3. So we went 4 pi over 3. That means there's 2 pi over 3 left over to complete that full circle. Okay, so that's kind of tricky. Let me just recap what I did there. In black here is our negative 4 pi over 3 radian measurement. We went from here all the way over there. Right, so you've got 4/3. So that means that you haven't quite reached 6 pi over 3. You haven't made a full revolution. You're 2 away. You need 2 pi over 3 more to make a full 6 pi over 3. I'm trying to think. There's probably another way to explain that easier. Yeah, we can do it like this. Like, here's a full circle. 2 pi, right? That's 1 full revolution around the circle. Okay, but we went 4 pi over 3. So we got to subtract that to find out what's left over for this red area here. And if you do that, if you get common denominators in those fractions, you get 2 pi over 3. Okay, you can always message me too if you're not sure where I got 2 pi over 3 from. That's critical because now we know where to put our dot. It's somewhere on 2 pi over 3, and we have to be 4 away from the center because that's what this first number is. So here's 1 away from the center, here's 2, 3, there's 4 dots, there's 4 units away from the center of the circle. So 4 comma negative 4 pi over 3 is this dot right here. Okay, if it's still confusing, maybe it's because like some of the skills that we did in this one, we kind of went over fast because it's assumed knowledge. It's okay, and you'll just want to go back and try to practice more about coterminal angles. Would be a good topic to look up if you had trouble with where I got that 2 pi over 3 from. And then I don't know, I guess that's kind of the big one. Radian measurement. If you're having trouble with that, you want to study radian measurement, or maybe it'll all make sense after you check out this next example. So we want to graph negative 5 comma pi over 4. So luckily we don't have to deal with negatives on the angle measurement. So here's pi over 4, right? It's right here on the as we're going around that circle. Pi over 4 is right here on this line. Okay, and now it's 5 away, but we're not going to graph just yet. Okay, so don't put your dot. 1, 2, 3, 4, 5. I think that's 5 circles away. 1, 2, 3, 4. Yep, that's 5 circles away. But however, since it's a negative 5, that just means you go in the opposite direction. So I'm going to go back down here, and I'm going to go on the same line in the opposite direction. I'm going to count my 5. Okay, 1, 2, 3, 4, 5. That's our dot right there if I counted right. 1, 2, 3, 4. Yeah, that's 5 circles away. Okay, so this tells you how far away it is from the center, and this tells you the angle measurement. So now let's just do one more, kind of seal the deal here, hopefully. Okay, so we got negative 3 comma negative 3 pi over 4. So since everything is in terms of positive radian measurements, let's take that negative 3 pi over 4 and convert it. Okay, this is a full circle, 2 pi. And if I add negative 3 pi over 4, the result will be the leftover angle, the angle from the initial side to the terminal side. Okay. So 2 pi, that's the same thing as 8 pi over 4 if I want common denominators. So negative 3 pi over 4, that is coterminal with 5 pi over 4. Okay, so we're going to want to go to 5 pi over 4 is over here. We're going to make a dot somewhere on this line. We're going to make a dot, here's 5 pi over 4, but since it's a negative 3, just like we saw in that last example, we need to go backwards on that line. 1, there's 1, 2, 3. There's our dot. Okay, so we graph this first one, negative 3 comma negative 3 pi over 4. We converted this to a positive angle by adding a full revolution to it. We added 2 pi. So that gave us 5 pi over 4. That's coterminal with negative 3 pi over 4. Okay, but then instead of going in the direction of 5 pi over 4, we had to go opposite because it was a negative 3 for r, for the first part of the polar coordinate. So same thing with this one, 2 comma 2 pi. Now remember, 2 pi is a full circle. So 2 pi means you're right back where you started at the initial side. And since r is 2, like the radius is 2, that means we just need to have a dot 2 circles away from the center.